everyone. Today's lesson is a review for Chapter 13, Coordinate Geometry. This coincides with the review out of the homework packet that you had, so that's what I'm going to go over. First question is to write an equation in point-slope form of the line with the given x and y intercepts. So just graphing this first, it's always good whenever you're trying to put this in any kind of equation for a line, it's always good to graph. So here we are, x-intercept is -3, so that's -3 right here. So that point would be -3, 0. A y-intercept of 2, so there we are right here, and that point would be 0, 2. Putting this in point-slope form, I need to use a point and a slope. So this one right here is pretty easy just to count up and over for your rise and your run. What you're trying to do is trying to find the equation of the line that goes through these 2 points right here. And I can use either one of these points. It's a lot easier, as you see, instead of it saying the x-intercept of -3, it's a lot easier to graph it, because then it's a little bit more clear to see the actual point, which is -3, 0. So I'm just going to use that as my point that they gave me as -3, 0. What I want to do is find the slope. So to find the slope, which is, of course, my change in y over the change in x, remember that you need to subtract your y's over your x's. So you have 2 minus 0 over 0 minus -3, and that makes plus. So my slope is going to be 2 over 3. So the equation that I have given this point and this slope is going to be y minus 0 equals m, which is 2/3, times the equation, or times the quantity x. Remember, it's opposite, so that's -3, this is +3. So this is point slope form. Had I used the point 0, 2 and put this in point slope form, I would say y minus 2 equals my slope again, which is 2/3, times x minus 0. And either one of these, this one right here or this point right here, using for point slope form, would be fine. Either one is correct. The next question says, write an equation in standard form. Now remember, standard form is where you have ax plus by equals c, where x and y are on the same side. A is the coefficient that is positive and an integer, meaning it has to be a whole number. So let's see what we have here. In standard form of the line that goes through these 2 points. So the first one is at 3, 0, okay? There's 3, 0, and then -5, -3, so -5, +3, so -5 up 3. So there's this point at -5, 3. So you're, again, trying to find the equation of the line that goes through these 2 points right here. Okay, so either one, you can pick either point. So I'm going to pick this point first, and I would say y minus 0 equals my slope, which I haven't figured out yet, times x minus 3. Or I could use this point and say y minus 3 equals my slope times x plus 5. Either one of those is going to work. I do need to find my slope, and I'm going to subtract my y's again. So my slope is going to equal, subtract your y's over subtract your x's. So we have 3 minus 0, so 3 minus 0 over -5 minus 3. And so we get 3 over -8. So this is -3 over 8, and this is -3 over 8. So what that means is I need to distribute and solve for y first and put it in slope-intercept form, and then after that, put it in standard form. So actually, I might need to have a little bit more room here, so we'll see. So we're going to go y equals, I'm going to distribute this, and I get -3 over 8x plus, and when you multiply this times this, remember, there's actually a 1 under here, and you multiply the tops by the bottom. So that's going to be plus 9 over 8. That's slope-intercept form. And now I'm going to move this to the left, and I get 3 over 8x plus y is equal to 9, equals 9/8. So 9 over 8. And remember, now I have the x and y on the same side, but for slope, standard form, this cannot be a fraction. So I'm going to multiply the entire equation by 8. And by doing that, when I multiply this times 8, the 8's cancel, and I get 3x plus, and then I multiply this by 8, 8y, and then I multiply this by 8, and I get equals 9. Okay, so my equation in standard form is this, 3x plus 8y equals 9. Had I done this problem instead, let's see what we get, equals negative 3/8 x minus 15 over 8, because remember, negative 3 times 5, which is over 1, plus 3. Now, again, you need to combine these two terms right here. Some people like to multiply by 8 right off the bat. I mean, you can completely do that, or you can just multiply by 8 over 8 here, combine these two terms, and then you get rid of the 8 later. This would give me y equals negative 3/8 x, and then this is 24. So if you think about this, 24 minus 15 is what? That's 9. So this is actually plus, 9 over 8. And this is going to also give me the exact same thing, which is going to be 3x plus 8y equals 9. And the reason is because, see, this is my slope-intercept form, right? This is also my slope-intercept form. It doesn't matter which point that you actually use in the beginning, whether you use this point here or the negative 5, 3. The point slope form will be different, but as you go down into slope intercept form, these two right here, whether you use this one or you use this one, see, these are the same. So slope intercept forms are going to be the same value. And then hopefully you get the same answer when you finish. The next question is these 2 points. So I'm going to actually graph this again. And I have 3, 3, which is about right here. And I have negative 3 up 5. So I have negative 3, 5. And I'm looking for the equation of the line that goes through those 2 points. So what I have here, again, is doesn't matter which point I pick. I'm just going to pick this one. Y minus 3 equals that's my, what is that? That's my slope times the quantity x minus 3. And the form that I'm actually using, just in case you don't remember, is y minus k is equal to m times the quantity x minus h. And that's where hk is a point that they gave me. That hk is a point that they gave me, like here, 3, 3 or negative 3, 5. And you do need to remember that, see, this is the opposite of k and the opposite of h. So that means when I put my point 3, 3 back in here to my my general form for a line, they're opposites. Okay, now I also need my slope, so I need to find that. So I'm going to subtract my y's. So I'm going to get 5 minus 3 over negative 3 minus 3, and I get 5 minus 3 is what? 2 over negative, 6? Negative 3 minus 3 is negative 6. And so 2 over negative 6 is negative 1/3. So there's negative 1/3. So solving for y first, not only am I going to move this negative 3 over, and that'll be a positive 3 here, but I have to distribute. So that's negative 1/3, so negative 1/3 x, and then negative 1/3 times negative 3. So that's what I'm doing is negative 1/3 times negative 3. Well, the 3's are going to cancel, okay? And negatives cancel, I end up with 1. So negative 1/3 times x is negative 1/3 x, and negative 1/3 times negative 3 is positive 1. So I get y equals negative 1/3 x plus 4. I need to move this to the other side to put it in standard form. So now it's positive 1/3 x plus y equals 4, and I'm almost done. This 1/3 cannot stay down there. The 3 cannot stay. So we're going to multiply the whole equation by 3, and we're going to get x plus 3y is equal to 12. And then that's my equation in standard form. Whether I use this point here or this point here, I'm going to get the same answer when I do that. The next question says, write an equation in slope-intercept form, that's your y equals mx plus b form, from the line that goes through this point, that's a point slope form, and it's parallel to this. Well, parallel lines have the same slope. So let's figure out what slope I can steal from this is. So let's find the slope. So negative y is equal to negative 2x plus 8. So I'm going to multiply everything by negative 1, and I'm going to get y is equal to 2x minus 8. Well, the only thing that I want to steal from this equation that my line is parallel to is the slope. And that slope is 2 over 1. So my slope for my new equation is 2. Here's my point. So I'm going to put it in point slope form. So negative 5, 0 is here. Up 2 over 1 is here. So my graph is going to look something like this. But let's put it in slope-intercept form. So we're going to go y minus 0. I'm taking the point that they gave me, 0, equals my slope that I stole from this equation because parallel lines have the same slope, times x plus 5. Remember, it's the opposite of both. If that's a minus 5, that's a positive 5. So I'm trying to put it in y equals mx plus b, so all I have to do is solve for y. So I get y equals 2x plus 10, and then the plus 0 is gone. So now I'm in slope-intercept form. Keep in mind that I could have graphed this after, instead of when I had the point and the slope, meaning I'm going to start up here at 10, that's my y-intercept, and then up 2 over 1 or down 2 over 1. Either one is fine. My next equation says write the equation in standard form. That's your ax plus by is equal to c of the point that goes through that point and is perpendicular to this. Well, what we know about perpendicular lines is they have opposite reciprocals. So that means we're going to start with this point, which is y minus 6 equals my slope, which I'm going to hold off on that, times x plus 1. So they gave me a point, negative 1, 6. So there's my point, negative 1, 6, but I don't know, I know it's perpendicular to this. Let's figure out what the slope of that is. The slope of this line, let's see, I'm going to solve for y. So I have negative y is equal to negative x plus 4. So I move the x over, okay? And I'm going to multiply by negative 1, and I'm going to get y is equal to x minus 4. Well, the slope is 1, right? So if my slope is 1, I know the slope of the line that's parallel to that is 1, but I don't want that. I want the slope of the line that's perpendicular. So that's going to be flip it over 1 over 1 and the opposite. So that'll be negative 1. So this slope is negative 1. So what they're saying is the slope that's perpendicular to this, down 1 over 1, would be something like that. So let's see, let's just solve because they want it in standard form. So I get y equals, distribute, negative x minus 1, add 6. So y equals negative x plus 5, and there we go. That means I'm up 5. Okay, let's see what we got here. Y equals up 5, down 1 over 1, down 1 over 1. So this line actually would go down like this. And then the line that's perpendicular to that does that. Okay, write an equation of the line that goes through negative 1, 6. So, but I want this line right here. Okay, and so that's why I had to take this value right there and take the opposite reciprocal of it. Perfect. Find the coordinates of the point of intersection. So we are given 2 points, 2 lines. We have 3x plus y equals 7, and we have negative x plus y equals 3. Graphing these, let's graph them. We get y equals negative 3x plus 7. That means we start at 7. We go down 3 over 1. My graph looks like this. This one is y equals x plus 3, starts up 3, goes up 1 over 1, and so this graph is going to go like this. So we are going to intersect somewhere over there. I want to know where we're going to intersect. So in order to do that, we have, I don't know, maybe 5 or 6 ways to solve that. You can solve it by elimination. You can solve it by substitution. When I say solve it by elimination, that means I would just probably subtract this quantity from this because I have both the same variable. 3x minus negative makes plus, so 3x plus x is 4x. Y minus y is 0, and 7 minus 3 is 4. So that tells me that x equals 1. I would take that value and I would plug it back into one of the equations, one or the other. So I have 3 times 1 plus y equals 7. So I have y equals, if I subtract 3 from both sides, I get y equals 4. So at 1, 4, my point of intersection is what I have, 1, 4. Another way of solving this could have been, see how I solve for y on both of these equations and to graph? I could, because y is equal to y, I actually could set these equal to each other. So let's say add 3x, I'd get 4x. Subtract 3, I get 4, and I get x equals 1 again. So you have, you do definitely have options of solving this, but that's just one way of doing that. The quadrilateral ABCD has coordinates. We have 0, 0. We have 5, 0. There's 5, 0. And this is B, this is A, which is at 0, 0. 3, 4, so over 3, up 4, so that's C, which is 3, 4, and 5, 0, and what's the other one? 8, 4, so 8, 4, and so this is D, which is 8, 4. And it says that, prove that this quadrilateral, which is this shape right here, connect the corners, prove that it is a rhombus. So, well, if something is a rhombus, you're going to have consecutive sides that are congruent. So I'm going to try to prove that this length is equal to this length. That's what I'm going to try to prove. So I'm going to find the length of CD, which I actually can just count over. 8 minus 3, which is 5. So I know that the length of CD is 5. Now the length of BD is, I'm going to use my distance formula for that. And so that means I'm going to subtract my x's. So I'm going to go 8 minus 5 quantity squared plus 4 minus 0 quantity squared. And I'm going to get, let's see, 8 minus 5 is 3. 3 squared is 9 plus 4. 4 squared is 16. So BD is equal to the square root of 25, which is 5. So these two sides are congruent. We just proved that it's a rhombus. Now I have to show that the diagonals are perpendicular. You always should try to come up with just sort of a conclusion, by the way. So you can say that since, or therefore, or, since CD is congruent to BD, and they are consecutive, congruent sides, then ABCD is a rhombus. Okay, you should always come up with some sort of conclusion. Next, we want to show that the diagonals are perpendicular. In order to do that, I need to find the slopes. And I need to find out if the slopes are, so I'm trying to figure out if they're perpendicular. So I need the slopes. So we're going to find the slope of AD. Okay, and so I'm going to subtract my y's over subtract my x's. So I'm going to go 4 minus 0 and 8 minus 0. So I get 4 over 8, which is 1 over 2. All right, now I'm going to find the slope of BC. Okay, and so that's saying, let's see here, subtract your zeros. I'm going to go 4 minus 0. I'm going to go 3 minus 5. 4 minus 0 is 4. 3 minus 5 is negative 2. I get negative 2. If the product of these two, so if the slope of AD times the slope of BC are, if the products are equal to negative 1, then the slopes are perpendicular. So we would say 1/2 times negative 2 is equal to negative 1. Therefore, therefore, the diagonals are perpendicular. That means therefore. Okay. Write the equation of the circle in standard form that has a center at negative 3, 1. And it passes through the point 5, negative 3. So over 5, negative 3. So we have 5, negative 3. And so what we have here is these two, we're trying to figure out, let's see here. The center is here. So that's my center. It passes through the point 5, -3. So actually, that's my radius. This passes through here, and so it goes like that. So that means that this graph somehow does something like this, okay? That being said, I need to find a couple of things. Number one, given the equation, let's say HK is my center. Let's say that's my center. The equation in standard form says that x minus h quantity squared plus y minus k quantity squared is equal to my radius squared, okay? This is my center, so I'm going to plug that in first. So I have x, do the opposite, see? That's your hk. So that's going to be x plus 3 quantity squared plus y minus 1 quantity squared is equal to my radius squared. So I need to find r. Now there's a couple ways of finding r. Number one, I could use the distance formula. Distance formula says subtract your x's, so I'm going to do that first. So -3 minus 5 quantity squared plus 1 minus -3 quantity squared. These make plus. -3 minus 5 is -8. Quantity squared is what? 64. And then this is 3 plus 1, which is 4. 4 squared is 16. So that means that my distance between the 2 points is the square root of 80. So this value, my radius, is the square root of 80. But here's the deal. This is r squared. My radius is the square root of 80. It's like a little bit less than 9. Because remember, the square root of 81 is 9. So it's a little bit less than 9. But what I put here is r squared. And what that means is this value here, I need to square that in order to find out what that squared value is. And so I just put 80 here. So that is the equation of my circle in standard form. Write the equation of the circle in standard form that has the diameter at -1, 5. So here's this point, -1, 5, and over 5 up 11. Here's 5, 11. And I'm trying to find the equation of the circle that has this as a diameter. So this is my diameter, okay? And what that means is that my circle is going to go around this like this because that's my diameter. It also means that somewhere in the middle is my center. And in order for me to find that value, I'm going to use the midpoint formula. So I'm going to find that midpoint. So I'm going to say to find the midpoint, which in this case is my center, I'm going to find the average of my x's and the average of my y's. So I'm going to go -1 plus 5. So you're adding your x's, divide by 2, add your y's, 5 plus 11 divided by 2. And so that's going to be 4. 4 divided by 2 is 2. 16 divided by 2 is 8. So my center is 2, 8. Okay. Once I have that value, if that's my center, what I can do now is start setting up my equation. X minus 2 quantity squared plus y minus 8 quantity squared is equal to my radius squared. Now remember, that value is radius squared. Two things. I need to find this value, x. That value, or I can call it r, that's my radius. So I'm going to find the distance between those 2 points. So the distance between those 2 points is going to be, subtract your x's. So I'm going to go the quantity. What's my equation? 2 minus 5 squared plus 8 minus 11 squared. So 2 minus 5 is -3. -3 squared is 9 plus 8 minus 11 is -3. -3 squared is 9. 9 plus 9, square root of 18. Keep in mind, this is my distance, which in this case is my radius. But I don't want my radius. I want my radius squared. So I'm going to take this value and square it, and I'm going to get 18. And so that's the equation of my circle in standard form. Write the equation of the circle in standard form. Again, in order to do this, I noticed that I do need to complete the square because I have an x squared term and an x. So I have to complete it one time. I have a y squared term and a y. I have to complete it again. So I have two completing the squares. So the first step to do is to just gather your common terms. So we have x squared minus 6x. I'm going to leave a space because we are going to complete the square. And then we're going to have plus y squared minus 22y. I'm going to move this to the other side, and that equals negative 121. In order to complete this square, what you're doing is you're taking half of the b term. Now, when I say b term, this stems from this, the quadratic ax squared plus bx plus c. So you're taking the half of the b term and you're squaring that value. So that's going to be half of b and then squared. So that's going to be half of 6, which is negative 3. But when you square negative 3, you get negative 3 times negative 3, which is plus 9. Keep in mind, this is an equation. It does have an equal sign. Anytime you do something to one side of the equation, you do have to do it to the other. So we do have to add 9 to the right if I'm adding 9 to the left. In addition to this, I'm going to complete the square here and take half of 22 is 11. Square 11 is, again, 121. And I'm going to add 121 to this side as well. Now, on the right-hand side, the 121s are going to cancel, and I'm left with 9. These are going to cancel. On the left side, the next step after I complete the square is to factor. So this is actually x minus 3 times x minus 3. You guys need to remember that this right here is always going to factor perfectly where this quantity is the same as that quantity. So this is going to be x minus 3 quantity squared plus this right here is going to factor also as y minus 11 times y minus 11, which is going to be y minus 11 quantity squared. Something to keep in mind, and that is that when you're trying to figure out, let's say you're not very good at factoring, if you're trying to figure out, what goes in these two terms, how do I know this is 11? How do I know that they're 11? You're basically taking the square root of that, 121, square root of 121, and you're taking the square root of y squared. Square root of y squared is y, square root of 121 is 11. Same with this. This is actually the square root of 9, which is 3. This is the square root of x squared, which is x. Anyway, here's my circle in standard form. Stating the center. The center is going to be 3, 11. And if r squared equals 9, then my radius is equal to 3. And if I wanted to graph this, I would say go over 3, up 11. There's the center. And then I'm going to go 3 in all directions. And in doing that, I'm going to have a little circle up there at the top. Use geometry or coordinate geometry to prove that the diagonals of a parallelogram bisect each other. So if we already know it's a parallelogram, I'm just going to use the same points that we used the other problem for. I'm going to call this B, and I'll call it A, 0. Parallelogram. Let's see these here. Let's see. What would this be? C, this is D. Let's call this, what are we going to call that? B, A, this is over A, up. I'm going to call that over, I guess I could make a parallelogram a square, but anyway, I'm going to call that over B, up C, and this is going to be over D, up C. Okay, we're trying to prove that the diagonals bisect each other. The diagonals are going to bisect each other if they're, well, actually, I can't use these points, can I? Because we didn't prove that it's a parallelogram. Okay, so I'm going to have to choose different points. What do I want to choose? I'm just going to make this a something right here, right off the side. If this is a parallelogram, I'm going to make this a square. So that's A over. This is A over A up, because that would be the same side. If it's a parallelogram, it has opposite sides congruent. And then we're going to call this 0A. If this is the case, what's happening is we have to show that the diagonals bisect each other. You use the midpoint formula. Okay, so we're going to say, let's see here. Let's find the midpoint. So that's AB, here's C, here's D. So we're going to find the midpoint of AC and the midpoint of BD. So, okay, let's do that. So the midpoint of AC, midpoint, is going to be equal to, add your x's, so 0 plus A divided by 2, and add your y's, so we get 0 plus A divided by 2. So what we have here is a over 2, comma, a over 2. So that's my midpoint of AC, okay? Now I need to find my midpoint of BD. So the midpoint of BD, again, add your x's. So we're going to get 0 plus a divided by 2, comma, a plus 0 divided by 2. We get a over 2, comma, a over 2. And you conclude, therefore, since my midpoints of AC and BD are equal, my diagonals bisect each other. Okay, that's all you have to do. Given this point, okay, so this one says, given the points 5, negative 8, so over 5, negative 8, so we'll say that's 5, negative 8, so that's S. And T is negative 3, negative 1. So that's going to be negative 3, negative 1. Okay, so given the points, find the equation of the perpendicular bisector of ST. Okay, so here we go with this. Here's ST, all right? If we have a bisector, that means it's going to cut it in half. What I'm looking for, basically, is this line here that cuts this in half and is perpendicular. So we actually have two separate things to do here. The first thing to do is find the midpoint. We need to figure out what that is. So we're going to find the midpoint first. And so in order to do that, again, you're going to add your x's. So negative 3 plus 5 divided by 2. And negative 1 plus negative 8, divide that by 2. And we're going to get 2 over 2, which is 1, comma, what is that? Negative 9 halves. Awesome. So that's going to be negative 4.5. So this looks like over 1, negative 4.5. This right here is the point of my midpoint. All right. So what that means is that my new line has to go through that. So that's important because that's my point, meaning all I need now is a slope that's perpendicular. And once I have a slope that's perpendicular to this, to my point that goes to this line, I'll have an equation of the line. So I'm going to start writing my equation. Y minus this, so it's going to be y plus 4.5 okay, y plus 4.5 equals my slope times x minus 1. Okay? And so what I need to do here is figure out what this value is. So I'm going to find the slope of ST. So the slope of ST. So subtract your y's over subtract your x's. So negative 1 minus negative 8 over negative 3 minus 5. So this makes plus. So negative 1 plus 8 is 7. And this makes negative 8. So my slope is negative 7/8. So find the equation of the perpendicular bisector. This is it right here. And so, I mean, I could simplify this a little bit if I wanted to and put it in slope-intercept form, but it didn't actually tell me to do that, so I'm not going to. Next question says, find the equation of the line that passes through this point and is parallel to this. Again, if it's parallel, we're going to steal that slope. So I want to steal the slope from this. So we're going to do that first. So we have negative 5y is equal to negative 3x plus 12. I'm going to divide everything by negative 5. And I'm going to get y is equal to 3 over 5x minus 12 over 5. All I want is this slope. That's what I want, is that one thing. Okay, by having that one thing, what that's going to do is that's going to give me point and slope. And so I can use that. It says the equation of it's parallel, so I don't have to change it. So here we go. We're going to go y plus 7, because I'm using this point that they gave me, is equal to 3 over 5 times x plus 5. Now, that's the equation in point-slope form. Done. Now it's asking me to put it in slope-intercept form, and that means basically I have to solve for y. So I have to isolate the y. So we're going to move the 7 to the other side. So we're going to go y equals 3 over 5. 3 over 5 times x is 3 over 5x. 3 over 5 times 5. If you're not sure what that is, you can do it over here. 3 over 5 times 5. 5's cancel. So that's plus 3. And then plus 7 here becomes minus 7 here. So y equals 3 over 5x minus 4. So now that's slope-intercept form, meaning I solve for y. The last form is standard form. Remember, standard form is ax plus by is equal to c. So that means this x and the y, see how they're on the same side? This needs to be brought over. So we have negative 3 over 5x plus y is equal to negative 4. So we're going to multiply this entire equation by negative 5. And when I do that, this multiplies. 5's are going to cancel. My negatives are going to cancel, and I'm going to get 3x. Negative 5 times y is negative 5y. And negative 5 times negative 4 is positive 20. So this equation right here is my equation in standard form, where the x and the y are on the same side, and not only are they on the same side, but also the x, this value, the coordinate in front of the x, which is my coefficient, has to be positive. Okay? Okay, cool. The triangle has vertices 2, negative 5. So 2 over 2 and down 5. So 1, 2, 3, 4, 5. Here's 2, negative 5. So A is 2, comma, negative 5. B is negative 3, 0. So here's B, which is negative 3, comma, 0. And C is negative 5 over 5, up 8. Oh, boy. Okay, so that's C, which is negative 5, comma, 8. So this graph looks like, find the slope of the median. Okay, here we go. So this goes like this, connects to here, and then connects to here. All right, so what they're asking is, find the slope of the median drawn to vertex A. So the median, so in a better picture, let me explain this to you. If that's vertex A, and I want to find the median, I first need to find I need to bisect this length. So I need to find the midpoint here, and then connect the vertex to the midpoint. That's what I'm looking for. So if I'm trying to find the median from vertex A, that's meaning I'm trying to connect it to BC. So I'm trying to find that value first, which is my midpoint, and then I need to connect this vertex to that midpoint, okay? So let's find the vertex, the midpoint first, and then connect it. So to find the midpoint, we're gonna, for the midpoint of BC, so let's do that first. So the midpoint is gonna add your x's, so negative 5 plus negative 3 divided by 2, and then add your y's, we have 8 plus 0 divided by 2. So that's going to be negative 8 divided by 2, which is negative 4. And this is 8 divided by 2, which is positive 4. So we have negative 4. 4 is my midpoint. And let's just call that M. Okay, so negative 4, comma 4. All right. So now that we have M for my midpoint of BC, okay, that's the mid. Let me see, BC midpoint. All right. We need to connect A to that. Okay, working on it. Check. But here's the thing. The actual question says find the slope of that. Now that we have that, we need the slope. So we need the slope of AM. That's what we're looking for now. So we're going to subtract our y's over subtract our x's. So we have negative 5 minus 4. That's my subtracting my y's. Negative 5, it's always the change in y over the change in x. So we have negative 5 minus 4 over 2 minus negative 4, which is negative 9 over 6. Divide by 3, and I'm going to get equal to negative 3 over 2. So my slope is going to be negative 3/2. The next thing it needs me to do is to find the slope of the altitude drawn from vertex B. Now, what you need to understand about an altitude is that altitudes are perpendicular, okay? Like this, see that? They're looking for the altitude drawn from B, to AC. And altitudes are perpendicular. So really, all I need to know is m, or we're going to call that the slope of AC. Find the slope of AC and then find the opposite reciprocal of that. So subtract your y's. So we're going to go 8 minus -5 over -5 minus 2. And so that's going to be what? 13 over -7. So that's the slope of AC. So the slope of the altitude, which is perpendicular, okay, is the slope of the altitude. So the slope of the altitude is going to be, flip it over, 7 over +13. And so that's my answer. Find the point of intersection of these two lines. Again, we did one like this before. Let's see here, and graph. So we have 3x plus y is equal to 5. And we have x minus 2y is equal to 4. So I'm going to solve these for y. So I'm going to get y is equal to -3x plus 5. And I'm going to get, now this one is going to have a little bit of work. So we're going to go -2y equals -x add 4. I'm going to divide everything by -2. And I'm going to get y is equal to 1/2 x. Let's see here, plus dividing by -2, so that's -2. So it looks like I'm up here at 5, and I go down 3 over 1. That's a negative slope, so it's got to go down right. And then this one is starting at -2 and going up 1 over 2, and this is going like this. So they're looking for the point of intersection, okay? So doing this, let me just make sure, -2y equals -x plus 4. I divided everything by -2, and I got y equals 1/2 x minus 2. Okay, this is what I want to do is just because they're both already set equal to y, I'm just going to set my y's equal to each other. -3x plus 5 equals 1/2 x minus 2. Now, a lot of people don't like working with fractions, and so what they'll do is they'll multiply the entire equation from the beginning by 2. You're welcome to do that. I'll go ahead and do that since I already wrote it down, but you don't have to. If you're comfortable with fractions, just start subtracting them, it's fine. So if I were doing that, every single thing gets multiplied by this 2. So it becomes -6x plus 10 equals 1x minus 4. I'm going to add 6x to both sides, and so that's going to give me 7x. I'm going to add 4 to both sides, and I'm going to get 7x equals, looks like 14, and x is equal to 2. So I need to go back up to the top and plug in 2 into any of those equations. I'm going to choose this one right here, and I'm going to get y is equal to -3 times 2, add 5. So I have -6 plus 5 is equal to y, so y is equal to -1. So our point of intersection is going to be 2, -1. Find the equation of the circle in standard form. We need to complete the square. We already did one like this, very similar. So I'm going to group my x's, so -2x, leave a space. I'm going to go plus y squared plus 12y is equal to 5. I'm going to complete the square. I'm going to take half of 2, which is -1, square that, I get 1, add 1 to both sides. Half of 12 is 6. 6 squared is 36. I'm going to add 36 to both sides. On the left, I'm going to factor. This is going to be x minus 1 times x minus 1, which is x minus 1 quantity squared. We're going to go y plus 6 times y plus 6 is y plus 6 quantity squared. So y add 6 quantity squared. And this is just 6 plus 36, add 6. 42. So this is equal to 42. My center is going to be 1, -6. My radius is the square root of 42. So if I were graphing this, if I wanted to graph this, I would approximate this. I would start off over 1, down 6, and there's my center. And then my radius is the square root of 42, which is the square root of 42 without a calculator is in between the square root of 49 and the square root of 36. Since this is closer to here, my answer is going to be like 6.7 or 8. It's not in between, so it's going to be closer to the 7 than it is to the 6. So we would go over 6.7, up 6.7, over and down. And so your graph would look something like that. Find the point of intersection of the following circle and line. So this is a circle. It has a center of 0, 0, and 10 is radius squared. So that means my radius is the square root of 10. Now, the square root of 10 is in between the square root of 9 and the square root of 16. So it's pretty darn close to the square root of 9, which is 3. So it's going to be 3 and some. So I'm not really sure approximately, but it's about 3 plus a little bit. This is a line, so negative y is equal to negative 3x minus 10. I'm going to multiply everything by negative 1, and I get y equals 3x plus 10. So that means that this graph starts up at 10, which is way up here, and it either goes up 3 over 1 or down 3 to the left 1. So not sure how this is going to intersect. If it is or not really sure. So let's figure this out and see if this is going to intersect or not. This graph possibly could look like this or not. Maybe it doesn't intersect. Let's see. We're going to find out. So in order to figure out if it intersects or not, we're going to plug in this equation. See this y? This is what y equals into this equation for y right there. So we get x squared plus y squared, which is 3x plus 10, quantity squared, equals 10. And so we're going to get x squared plus 3x plus 10 times 3x plus 10 equals 10. We have x squared plus, now we're going to FOIL. I've got 9x squared plus 30x, which makes plus 60x. 10 times 10 plus 100. I'm going to move the 10 over and set it equal to 0. It looks like I have 10x squared, 9 plus 1, plus 60x plus 90 is equal to 0. I'm actually going to divide this entire equation by 10, including 0. So including doing that, I'm going to end up getting x squared plus 6x plus 9 is equal to 0. This is going to factor super cool. X plus 3 times x plus 3 is equal to 0. X plus 3 quantity squared equals 0. And I'm going to square root both sides to solve. And I get x plus 3 is equal to 0. X equals negative 3, which means that I now have to plug this back into this equation right here. And so by doing that, I'm going to get y, my y coordinate. So y equals 3 times x. X is negative 3. Add 10. And so we get y is equal to negative 9 plus 10. So y is equal to 1. So actually the one point of intersection is negative 3, 1. So it looks like right here, that's my point of intersection at negative 3, 1. So it just like touches it super close, then ends and then leaves. Doesn't intersect it, because keep in mind, if in fact this intersected, it doesn't like go through twice. It doesn't pierce it, because then I would have 2 points of intersection instead of 1. But because I just have 1 point of intersection, it just touches it in one place. 17, determine if the lines are parallel, perpendicular, or neither. Well, we need to find the slopes for both of these. So I'm going to solve, okay, let's see here. 3y is equal to, I'm taking this equation here. So 3y equals 2x plus 15. So y is equal to 2/3 x plus 5. What I did was I divided everything by 3. So this is the equation of the first line. The second equation, 6x, so I'm going to go 4y is equal to negative 6x plus 10. Y is equal to negative 6 over 4x plus 10 over 4. I'm going to reduce this 6 over 4. What is that going to be? Divide by 2. So I get negative 3 over 2. And so I've got -3/2 and 2/3. Let's check. What do you get when you get 2/3 times -3/2? 2's cancel and make 1. 3's cancel and make 1. 1 times -1. Guess what? They're perpendicular. So if their product is -1, then the lines are perpendicular. So you would say the lines are perpendicular. And you can also graph those since I've already solved for y. I mean, it's pretty easy now. Start at 5, go up 2/3. Okay, there's that line. The other line, where is it? Here. Y equals 10/4. So 10/4, what is that? 5/2. 2.5. So I start at 2.5. And then I go down 3/2. So that's like this. So my point, so I don't know, it didn't ask me what the point of intersection was. It just asked me if they were perpendicular, which they are, because they have the opposite reciprocal slopes. So that's the conclusion of the Chapter 13 review that's in your packet. I hope that helps, and thanks for watching.